Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, everybody. How are you all doing? I hope you are happy and safe and healthy. This is Krishna Bedula from IUCE, and we have our team from IUCE, IFEES, and GEDC with us. Dr. Hans Hoyer and Aliki Papas are here also to welcome you, and Hans will make some comments towards the end of the presentation. But before that, I would like to welcome you all to this another one of our very interesting webinars. In fact, we got some amazing things for you today from our partner Althea and the faculty and students from Nelson Mandela University in South Africa. It's a very timely topic: virtual project-based learning involving computer-aided engineering and data analytics. So, without much ado, I will hand this over to Dr. Armin Weitel from Althea, and I'm going to make him the presenter, and he will take it from there. So, Armin, I'm going to make you the presenter, and
thank you very much. I will check to open the right screen. I hope
perfect.
You can see that.
Perfect.
And during my presentation, I will turn as well my camera on so that you see me, myself. Thank you, Krish. Thank you, Maliki and Hans, to give us the opportunity to join your webinar series. I'm very glad to be here in a virtual way. And the first 10 minutes, I would like to introduce Althea and Althea's global academic program, and hand over later to Clive and Charl to take from there. So Althea is a global company. Does that work? Get to the next. Yeah, is a global company and is specialized in simulation in the virtual development of systems, of mechanical systems, and design, modeling, visualization, as well in the CAE part with a lot of solver capabilities. In the latest years, we added capabilities for data analytics and Internet of Things, which is key, will be key in the future. And we will see as well how universities adapt to that challenge for the future. And in addition, we have solutions for HPC, cloud computing, and we have partners who complete our offering with their specialized offers. So this is about Althea. I don't want to go deeper in that, but all we do inside of Althea is actually following the vision of our founder and CEO, Jim Scapper, that we want to transform the customer decision making with simulation, data analytics, and high performance computing. So this is the target, the vision of the overall company, and our my team around the global academic program is actually preparing engineers to make these decisions, to be familiar with simulation, to be familiar with data analytics, to understand where these tools can help, where these tools have their limits, their boundaries, and to meet the challenges in the future. So this is our goal, to have these engineers coming out of school being prepared, working with the challenges, meeting the challenges. And we want to do that helping the people who learn, actually the students, working with our tools, working with these challenges, but as well working with the teachers as they know the best how the students learn, what they need, and how they all the knowledge can be transferred to them. And the third party are the people who do the researches, the PhD students, the master students, doing their PhD thesis and master thesis. We support them as well with a special offering, and we try to meet their requirements, their requests in a different way. The students more in a forum, in a lively support forum where they can get help when they use our software, which they can get free for free license requesting in the internet. And we support as well student teams with sponsoring packages We support them as well with learning packages when they try to compete against each other in these competitions. For the teachers, we have a straightforward price model meeting their requirements, and we award classroom usage, as this is key for us to see that the students work with our solutions and get familiar with all these technologies. The software has no limitations, and we have a wide range of content as well in our libraries to help teachers building curriculums and build their courses. And for researchers, we give open APIs so that they can build their innovative solutions on top of our the programs, tools, and we get them in touch with our experts internally inside of Althea. So these are the basic offerings that we have. And as well, the last months challenged us as well with all these COVID situation. But we saw that we were quite well prepared as most of our content, or actually all of our content, is online, hosted on our webpage for universities. So student offerings, teacher offering, learning library, and a lot more is online. And in the last months, we created an additional, a kind of a flyer. It's more a summary of what we are offering based for 5 target topics here: manufacturing, analysis, kinematics and dynamics, robotics, and electromagnetics. So you can see what we offer in these fields, and have direct links to ebooks, to tutorials, to online courses, and of course the software packages used for these topics here. So these are more the general things, and for the simulation and in the virtual world. Here, a special offer or a special solution that we just created together with a company called Chrome, which is professional in lab systems, because we think that students, or actually myself, know that by myself, that I love to have something in my hand, to see something, to touch something, and not always live in the virtual world. So we combine the reality and the virtual world within the partnership of Chrome and Althea. They have these lab systems. This is a ball balancing table, and we contribute with the control system to it. Does that work? Yes. I hope you can see the video. It's the ball balancing table, and here you see the control system and activate. You control by the system itself, automatic control, or manually here, and see how stable the system works and the reaction time. And if you would like to, you can build a challenge, for example, for your students to control the ball rolling through a maze in a most efficient way. And that is always exciting for students to see. And they, by playing with that, actually, they learn how these control systems work, how the interaction is between the virtual world and the reality, the digital twin. And the second innovative solution we just launched is the combination of a written script, actually the knowledge, the script, the textbook, and scripting in the combination. So when you have a text, for example, as a teacher, you would like your students to read it, to understand it, then you can do as before in like a PDF. You have all your formulas, your method description inside, and you combine it with an active script where you can go in, change the formulas, see the results later on. And this is what it looks like in action. It is web-based tool. You have your text, your graphs, your math here, and in between integrated, these mathematical formulas become actually living life, because you can execute them and you see the response, the values, the results directly, immediately. And later on, you see how these formulas, how these principles that you have learned as a student in the text get lively reality, actually, kind of reality, and you can compare different parameters, for example, of a pendulum and with different damping values here, and you see how that working. So as a student, you can combine both. You learn something and you explore by yourself, and that is quite attractive for everyone who want to explore by himself. So some ideas and an overview of what we are doing. And I'm really happy that with Clive and Charl, we have two partners in South Africa working with us together. And Clive will more concentrate on the classical mechanical engineering, control engineering. And I'm very happy that Charl is exploring the new technologies with data science and IoT, which is key in the future. And that is very promising that young experts go in that direction and exploring all the possibilities. So I want to thank you for listening and hand over to Clive and later on Charl. Thanks.
Okay, I'm going to make Clive the presenter now. Just a second. Clive, you just have to click show my screen.
Yeah, I'll just show it now. Are you hearing me clearly, Krishna?
Yes, we can hear you very clearly.
Okay, terrific. First, I'm going to get a move on because I've got quite a bit of stuff that I want to get through. So first off, thank you to all of you at both Althea and to the IUCE and IFEES guys for this opportunity to present today. What we are going to do today is we're going to present on what we do in the space of project-based learning by giving you an overview of our various projects, as well as our. Are you seeing my correct screen?
Yes.
Sorry.
We can see your screen. Yeah. Right. Yes, you're all set.
As well as our move into project-based learning in data analytics via one of our brand new and possibly most exciting ventures that we've got going on here. So in terms of who we are, we're an engineering engagement group that focuses on design for lightweighting, additive manufacturing, utilizing topology optimization, as well as generative design, biomimicry, conceptual design, and Industry 4 design integration aspects. In other words, anything that is new technology, we are very interested in. We deal with projects that are primarily student-driven, and they feature cross-institutional industry and private sector participation. The focus is on producing physical and functional outcomes that promote and encourage engineering design utilizing the very latest available technology. We also employ a project-based learning strategy, which enables our student volunteers within our design group to fast-track their skill sets in quite a diverse range of cross-disciplinary applications in the various projects. Now, first of all, where are we? For those of you that are not too aware of South Africa, we are basically on the southern tip of Africa, and we are based in a town called Port Elizabeth, which is right at almost at the extent of the continent. And furthermore, I can give you a little bit of an overview of our campus here. This is our South Campus, where we are in relation to this is immediately adjacent to our South Campus, and I'll show you that shortly. The Althea guys that are based locally, that have been very strong partners in what we've done over the years, are based in Stellenbosch, and that is about 1 hour's flight away from us, or 725 kilometers, about an 8-hour drive. And here you can see a bit of an overview of our adjacent North Campus and where we sit in our little lab in terms of the whole structure. Now, in terms of projects, initial projects that we've been involved in the early 2000s, we were involved in the normal standard university projects like the Baja SAE, which we competed in for many, many years. But in 2012, we took on a big project in that we designed and developed a solar car for competition in the South African Solar Challenge, which was an international event circumnavigating South Africa on a 7,000-kilometer odyssey over a 2-week period. So it was an absolute immense competition to be involved in, and fantastic for the student designers. Now, bear in mind, the students completely designed this car on their own. I've got a very short little video showing the car traversing one of the highways somewhere in the inland here. Hopefully our driver will give us a little bit of, there we go, a bit of a wave. Now, why NMU and Althea? Where did this come from? This actually stemmed back to this article that you're seeing on the screen right now back in 2012, which referred to topology optimization techniques used on the Red Bull Formula One car's front wing to leverage flexibility for aerodynamic gain. And this was followed up shortly by a presentation that I saw online for the Lotus LMP2 Cup that was presented at the 2013 ATC, the Althea Technical Conference in Europe, where the rear pillar was optimized using OptiStruct, resulting in a remarkable 54% mass reduction and a remarkable 205% stiffness to mass ratio gain, which was absolutely eye-opening. And this led to me essentially sending an email to Althea in Michigan, and very shortly thereafter, and much to my surprise, the local Althea guys got in touch with us, and our whole incredible journey started. We moved on from this point to a new project in 2014 called the EcoCar, and this is something that happens on the Asian continent, the Americas, and Europe as well. So it's a well-established competition, but this was the very first time it was being inaugurated in South Africa, and it was primarily concerning the lightweighting and efficiency in terms of the design. So our students basically designed a full carbon fiber vehicle here, and having the Althea tools available to us really helped the process in terms of maximizing that efficiency. As it was, we were to go on and to win the event in the ICE category for 3 years in a row, setting multiple subsequent records along the way. And we eventually got Althea on board to actually sponsor the project over the final 2 years, which was really great because it gave the project a little bit of sustainability. There's just a short few videos here on the vehicle on its way. In parallel to this, around this time, we also received additional funding to develop multiple online e-learning modules for technical high schools or secondary level schools in the country. And this opened up an entirely separate project area. This then expanded into the development of online modules for mechanical engineering subjects. And we have received excellent feedback from our students over the years that they've been exposed to this, and it has now become a default part of their tuition. We've also provided various short learnership programs, which we call SLPs, for industry and student use as well. You can see on the top left there, there's a screen capture of an FEA package that we developed. And we've also got in the top right-hand corner there, which you can see animating, was a little bit of a luxury item that actually both Charl and myself worked on, which was an app that we developed, a standalone app for the EcoCar, which was used primarily as a marketing tool, but also as a testing ground to see what we could do with interactive e-learning techniques, because this was one of the challenges that was presented by e-learning, was to make sure that the viewer actually interacted with what you were trying to get across to them. And now this has become, obviously this year, considerably more significant due to COVID restrictions. So the 5 years prior to this, that we have developed all these different platforms, and they now move into the hundreds of platforms that we have developed. And learning from all the challenges and mistakes that we made along the way has proved to be actually quite fortuitous for us, and is now expanding across the entire institution. We were also introduced roundabout at this early stage to the Ulti University platform, which Armin has already alluded to in his part of the presentation, and which features the expansive free student edition, which all our students have access to, specifically in the group, because we focus on the more higher level stuff there. But in coincidence, Althea had been developing their online e-learning capability in support of the various platforms that they were introducing. So if you look at the online courses option on the Ulti University site there, that will take you to the various options that Armin has already alluded to. Now, when we attended the 2017 ATC in Frankenfeld, Germany, we formally met the guys. At that stage, it was Matthias Gulke, and we were able to find much common ground in addition to just the use of the platforms, the software platforms themselves. And that was in terms of the e-learning platforms that we developed as well. Now, the Ulti University platform has also, over the years, has expanded and formed considerably, which covers most of their platforms, and it has proved to be a very valuable resource for our students, both in our projects. But what we've also managed to do is we have managed to include some of these online courses into our subject modules to enhance the subject modules, because it's not just a matter about learning the platform. Within those online modules, there's a lot of relation to actual theory that engineers are exposed to. And the nice thing about these is that the students are able to complete these in their own time, at their own pace, on their own devices, and in their own homes. And this is one of the major advantages of e-learning as a scaffolding device and a support device to traditional lectures. Furthermore, on that online learning platform, you've got the certification courses, and that allows interested students to expand further into more advanced topics, which they then receive a certificate of completion, which can then be added to their resumes and presented to future employees. And in addition to that, which I don't show on the slide, you have got an excellent learning library where there are many, many videos and a fairly comprehensive ebook selection, which I really, really recommend that the students that you're dealing with, or both academics and students, go onto the site, register there, and use the resources, because they get more and more comprehensive each day. And we have, in the last couple of years, been communicating with the Ulti University guys as to how we can further develop this as a repository for engineering examples that could be used by academics in classes. So I really, if you have not gone onto that site and registered there, and it's very, very easy to do, please go ahead and do it. You're going to find that your students are going to really love it. And it also takes quite a load off the academic in terms of having to teach them the platforms. We've used it for some solid OptiStruct, Inspire, and Inspire Studio, because those are the platforms we use a lot. But it is considerably comprehensive beyond just those platforms. In addition, what we have managed to do is we've established a network of collaborators. Project-based learning would be quite pointless if it were not relatable to real-world applications. And we've worked particularly hard to establish a network of academic, industrial, and private sector collaborators that have rooted our project outcomes in the sometimes harsh reality of the real world. And there's just a brief overview of the various people that we are involved in from an academic and private sector point of view. Now, as academics, we've all probably heard the statement, there is theory and then there's the real world. And most of us will very often learn that these two options sleep in separate ditches. Althea has been very crucial in helping cement this collaborative network within South Africa in our partnership with them, and also drive it forward. And it's actually resulted in many of our projects coming to life. You'll find that our private sector partners are also very proactive in collaborating with our students throughout the project life cycle, be it in the form of advice, material supply, manufacturing options, and sometimes even funding. And that is absolutely crucial to any type of academic venture that is outside of a standard curriculum scenario. This has also been invaluable in terms of the development of our young student engineers, as it helps fast track their knowledge base beyond just academia. And it's important to note too at this stage that our student team members are given freedom, and they're encouraged to use their imagination and creativity in their design outcomes, and to explore these new technologies as much as possible, not to be afraid of them, with minimum interference from myself and any other academics. It also, on virtually every single instance that we've encountered over the last 8 years or so, has led to our student team members acquiring excellent employment opportunities too, which helps close the loop. Now, what I'm going to do in the next section is overview highlights of the various projects we've completed in recent times, and I'm going to scoot through these quite quickly because we are quite tight on time. One of our first major ones was the carbon fiber wheel. This was primarily a lightweighting project intended for use in the eco-car, which is effectively our rolling test bed. It was also a master's project and one of the very few examples in our country of a bespoke optimized carbon composite design. As such, it was quite a complex project, utilizing conceptual design. There was topology optimization initially in there. Then we used OptiStruct's composite layup optimization capability. We then got help from one of our private sector partners, CustomWorks, in terms of the manufacture of 4 wheels and then installing them, testing them, and using them long-term on the eco-car. Martin, the student that you see there, used a combination of these tools, but specifically an Inspire and OptiStruct and HyperWorks to produce the final outcome, which we are really, really proud of. As a result of this, he was also invited to present his work at the 2017 Althea Technical Conference, or ATC, in Frankenthal, Germany. And the project was also a finalist for the 2017 African Advanced Manufacturing Innovation Award. These wheels now have been on the eco-car for over 3 years without any issues whatsoever. And one of the unique aspects of the project was it was one of the first projects worldwide to utilize brand new composite design failure theory in consultation with the originator, who is a composite guru, that is Professor Stephen Tsai, based at Stanford University. And this is the same Tsai that, for those of you that have been involved in composite design, that is the name in the Tsai Wu and the Tsai Hill composite failure theory. So we were dealing with quite an amazing guy here in terms of the development of that project. Our next little project was a seemingly insignificant one, but it saw our first move into metal additive manufacturing. And despite its apparent simplicity, it was to prove pivotal in moving our future projects forward. We had an introduction by the local Althea guys to Stellenbosch University CT Scanning Center, and their top scientist there, Professor Anton Duplessis. He was planning a round-robin test of an actual functioning component across multiple metal additive manufacturing centers on titanium additive manufacturing structures, and he needed a quick solution as a test component. So using specifically Althea Inspire with its superior topology optimization capability, the component was quickly produced and sent off for the round-robin tests, and I think it was 7 to 9, I can't quite remember offhand now, centers that this was all tested. The component was planned to replace the original bracket on the eco-car, which was a carbon fiber bracket, and it was really light. It was at 49.5 kilograms, but our final optimized bracket in titanium, as you can see there, came in at 29.33 grams, which was quite an amazing achievement. Furthermore, this little bracket ultimately resulted in 3 times research papers, and we also hosted an ASME global webinar where we detailed the actual process. It has also shown up at multiple international conferences. Some of them we haven't even known about until after the fact. We just seen that our little device has been shown there, as well as this very nice article that you see on the screen there in the Metal Additive Manufacturing magazine. The next project for rear drive support on the eco-car, and this was our first major foray into lattice design as part of a lightweighting strategy. It proved to be a valuable learning process in terms of design challenges for additive manufacturing and the challenges one faces when employing lattice design as part of a strategy. The results were very beautiful and rather strange, and to everybody, including ourselves, it seemed like they wouldn't even work, despite all the simulation and analysis behind the design. But they were installed onto the eco-car, and they exist there until today, and we won 2 of the national events with the structures on the vehicle where they performed absolutely perfectly. The next project was as a result of a need to replace a rudimentary steering wheel in the eco-car with a solution that was custom designed to include integrated telemetry and cabling, an ergonomic custom fit for the driver with all driver controls within finger reach, as well as a quick release mount. We did multiple design iterations here, and the final design was printed by Rapid 3D and polyamide nylon on a 3D Systems Pro X500 and dyed black using their dimension machine. It featured internal ducting for electronics, telemetry controls, and a minimized lattice infill to keep the structure as light as possible, as well as featuring a pedal throttle behind the steering wheel main facade. This next one, and I apologize for going through quite quickly, but we're quite tight on time, was hatched at the 2018 Wrapup conference. That's an additive manufacturing conference in South Africa at the suggestion of Prof. Du Plessis. The objective was to produce a bespoke titanium mountain bike frame that could be printed in one piece without welding, and which at the time would have been one of the largest metal titanium 3D prints in the actual world. The student that was involved in this was Byron, and he was able to do this project as part of his BTEC qualification. So we were able to kill two birds with one stone. It was a very complex project, and it really pushed the limits of the software capability at that stage, and was based largely on a topology optimization strategy based on the international codes for these type of applications. And it resulted in a very beautiful design that again defied logic in terms of its capabilities, and it would be producible at a competitive price compared to top-of-the-line carbon fiber mountain bikes currently in existence. It was completed with the collaboration of Akani 3D and the 3D Innovation Research Group at the University of Stellenbosch, and it also featured in a starring role at the 2019 Wrapup conference, where Byron presented his work, as well as at the 2019 African Advanced Manufacturing Conference. Furthermore, we entered into the Permundus Challenge at Form Next, which was held in Frankfurt in 2019, and the design won the Public Choice Award, which was really an outstanding accolade for the amount of work that he put in. The very next project, and this strange-looking device here, was a metal additive manufacturing project necessitated by a rule change in our eco-car competition, which required foot-activated brakes on the vehicle for future events. The objective was to design and manufacture a one-piece brake support structure that was lightweighted to the extreme. It could take all the required loading, and which could fit seamlessly into an extremely confined space within the eco-car, but yet integrate into already existing braking components. The project proved to be an excellent design for additive manufacturing project, and helped seriously advance our knowledge base in this area, as we were going to hit multiple stumbling blocks in the design process. Quite late in the project, we realized that the existing design would be very expensive due to the significant support material required in the print. So a last-minute redesign phase was undertaken to completely eradicate these supports externally and to severely restrict inner supports as well. Now, this had the impact of reducing the additive manufacturing cost by 75% from the initial design, which was absolutely amazing. And because of time constraints, we also left some more percentages on the table. Again, our collaborators, Akani 3D and the 3D Innovation Research Group, were invaluable in getting this project to completion, and the structure that you see on the screen there was printed on Akani's EOS M290. We also presented this at the, oops, sorry, I'm jumping ahead here, little slip of the finger there. We also presented this at the 2019 Wrapup conference, and it won an award there for the best design in the transportation category. You can see the designer Zahid there, he's our current team leader, and it is currently fitted into the eco-car. Now, our next project here is an inherited project which has only been partially developed and is intended for both competition and the international cyberphysical event, as well as a long-term development of a cheaper orthotic for amputees. The picture that we're seeing here is still very much in development, so it's in its early phases, and there's much work to be done by the end of the year. Here you'll see the original design that we inherited being tested. And it's a really interesting project because it features cross-disciplinary disciplines or focus areas, including structural design with additive manufacturing, electronic integration, control system integration, and sensor feedback integration as well. The project is broken up into three distinct sectors: the hand, the wrist mechanism, and the socket, and all individual parallel design projects in and of themselves. The final screen that you see here is the socket. We did a detailed scan of the current amputee's arm for bespoke socket design, and that was then 3D printed out and is now being used as the basis for development of the actual socket itself, and will continue through the year. This project was COVID-driven as a result of urgent need by the anesthesiology doctors at a local hospital to help with the containment of aerosolized droplets when intubating patients for in-theater procedures. While there are many of these devices floating around worldwide, excuse me, very few focus on extraction of aerosolized droplets, and thus become infection focus zones and provide a serious risk to healthcare workers. This was actually a remarkable project because, although simple in appearance, was quite involved due to the constraints within the theater itself, as well as the procedural requirements required from the doctors. Furthermore, what hindered us was that the students were all under shutdown at the time. So the entire project, including the prototype, had to be completed remotely. And this was done in an amazing 6 days. At this stage, the prototype was then tested in theatre by the anesthesiology staff, who then recommended small upgrades and improvements to the design. And finally, after a lot of red tape that involved medical equipment, funding was secured from a local government agency, and the intubation unit was recently deployed to the hospital, where you can see in that picture there, the doctors are foot shaking as per social distancing requirements on first delivery, and it is now planned to access further funding to roll these out across the country. There's also being a patent being applied for by our licensed manufacturer in this respect. A secondary issue in COVID response is this amazing project, which was started by some of our students to an urgent need for ventilators in this country, and it's something that we're being challenged with across the world. These students have started their own startup at the NMU's incubator facility and started development on the device just prior to the national shutdown. They've already gone through multiple phases of registration of the project and are the most advanced ventilator option in the country presently in terms of being in the final phase of approval for production. The current ventilator is well beyond a standard CPAP device in its current configuration, and we have just sourced further funding to expand the development into a full BPAP device for mass distribution around the country. I just want to take a sideways step here into engineering tuition and the challenges we may face. We all know universities are difficult to and reluctant to change in a lot of respects, and for the simple reason that change does have implications. Our qualifications are very complex things, and they're all intertwined. So any mercenary actions by academics in any modules can have significant effects. Added to that, we also tend to find that some academics can be quite obstinately stubborn to accept change, although that only applies to some. Hovering over that and anchoring that is that the fact that our content is largely sacrosanct and largely built on a fairly rock-solid physical platform. And there's no, also in tandem with that, there's no ignoring the overload faced by both academics and students. But we're all challenged by an urgent need to stay relevant in the face of rapid technological changes. And this is where the Althea platforms can really help facilitate that. In addition to that, we're right in the middle of a technological revolution, and further advent of the fourth industrial revolution approaches us like a freight train. So in terms of our group, we have embraced specific game-changing focus areas that we consider to be game-changing, and that is additive manufacturing, lightweighting and optimization, the Internet of Things, data analytics, and AI and machine learning. And these last two items I'm going to return to a little bit later and so sharp. We used to find that life cycles used to be quite predictable, but now we're in a situation and scenario across the board where cradle to grave can occur in just over a generation. And this can be very intimidating for academics. But what we have found from our own point of view is change is always good. You just have to actually embrace it. Now, it is clear that there's a need for a paradigm shift in the way that we do things, and COVID has just enhanced that actual need. So if you consider this statement here that I've got up on the screen, I would like to make a small edit to it and change that many challenges to more fun, and redress the statement to more fun for the future engineer and for the academic too. So the narrative can be changed from one of fear and intimidation to fun and excitement if you embrace it, for both academic students and also for our conservative industry tribe as well. To me, it's clear further that the old ways are increasingly not fit for purpose in terms of the way we used to do them way back when, because we live in a very different world than which we grew up in, and then there's no place for sentiment in that any longer. Furthermore, connectivity evolution has opened up the world of academia into a global village, and as academics, we really need to adopt a 21st century mindset, because our students already have grown up with that and have that hardwired into their systems. Now, jumping away from that and back into our projects, and leading to what Charl is doing, I'd like to revisit the final two game changers I had there, the Internet of Things and data analytics. We tried an early foray into basic data analytics and IoT associated with the EcoCar telemetry system some 2 years ago. We wanted to relay our telemetry and sensor data on the vehicle to both the driver via smart glasses and to the pits in a real-time scenario. At that stage, Althea had acquired Carriots, which allowed the flow of data to the cloud and back. And this is now morphed into SmartWorks and is considerably more powerful than it used to be. It was still very early days for us, though, and we only made partial progress on the system. And we specifically battled with the real-time aspect of things. We had to resort to actually downloading the data each time the car pitted, and we simply ran out of time in terms of developing the project. Now, keep the ideas of this project in the back of the mind while I digress slightly into another project that segues into Charl's area of research. This project consisted of a final year project that our group assisted on. The idea was to conceptualize, design, and build a affordable custom SCARA robot with organic 3D printed structural members, custom designed PCBs, an inbuilt vision system, and an IoT browser-based control system. So it was an extreme cross-disciplinary device to my mind, and encapsulated all aspects in respect of what we consider what the fourth industrial engineering is all about. The designer, who's Charl, as you see on the right-hand side there, is our next speaker by way of early introduction. The robot arms that as you see at the top there were designed using embedded wiring and a topology optimization strategy, and utilizing multiple Althea software platforms to achieve this. It also featured a really unique and very cool compliant mechanism for the robot gripper, which was printed all in one piece using 3D printing, and this was facilitated by our collaborators at Wrapup 3D. The entire robot could be controlled by an app on a cell phone, and it was demonstrated at the 2019 African Advanced Manufacturing Expo, and it so impressed a director of a local company that Charl was able to get a job directly from his work on this project. And this leads into our very latest project, which involves real-time manufacturing data analytics, which is really cutting edge. And it also happens to be just a significant strategic focus of Althea worldwide as well in terms of their new suite of packages. I'm now going to put you in the capable hands of Charl to take you further and to give you more detail on the areas where his master project is going to go on this deeply fascinating subject area.
Thanks, Clive. The concept of the project is to develop a CyberPhysical IoT system to support real-time and cloud-based predictive data analytics and process optimization. The intended system comprises of three major components, the first of which is the development of a smart IoT sensor to non-invasively gather and process data from the mechanical process and wirelessly stream this data. The second component would be a cloud system where the sensors are managed and their data is ingested into the cloud, processed and stored. And the third component would allow for the visualization of the data remotely and in real time. So sensor networks form the physical component of the cyber-physical system. So without penetrating the automation layer of the mechanical manufacturing process, the sensors are designed to extract the process information based on metrics such as vibration, temperature, humidity, and pressure. The sensors process the data, performing analytics such as spectral analysis and data aggregation, and then these results are then wirelessly transmitted into the cloud. Regardless of the platform and environment which hosts the cyber components of the system, the following elements will be needed to construct the IoT system. A messaging system is needed for the sensors to connect to and ingest the data into the cloud platform. And then a device management system is needed to manage the sensor network and differentiate the sensor data. A service is needed to host real-time data processing, where the predictive data models can be deployed to analyze and extract features from the sensor data. And a cloud-based storage facility will be needed to make the solution portable and scalable. And then the user will need a real-time visualization platform to visualize the data and data features. The next two components don't necessarily need to be hosted in the cloud, but the stored data is used to develop machine learning models to provide predictive insights into the manufacturing process, and then possibly larger data analytics can be done on historical data. The trained models can then be deployed into the Stream Analytics platform. Most times, not all possible variables can be taken into account when initializing a multi-stage manufacturing process. And then often the process information is not looked at until the process is finished. So this project aims to use data-driven models to give real-time predictions on process parameters so that these process parameters can be optimized in real time while the process is still in action. From our research, many of these cloud-based platforms exist which ingest sensor data and have device management. However, most of the platforms don't provide real-time visualization tools, and their real-time data analytics platforms are very limited. And developing and training machine learning models is also complicated and requires skill even with common resources such as TensorFlow. So the Althea Knowledge Studio is a great platform which reduces the complexity of preparing data, building and training machine learning models. So this tool will be used in the project to develop the predictive models, which will be used to analyze the sensor data. And the Panopticon is the Stream Analytics platform and the real-time visualization tool, which will be deployed in the cloud and will host the developed predictive models, which are built in Knowledge Studio. Panopticon's real-time data visualization tools will be then used to view the data and give feedback from the predictive models.
Great, thanks, Charl. Guys, sorry we've run over a little bit there, but we had a lot to get through. Christian, we'll hand over to you, and we'd be welcome any questions.
Fantastic job, you guys. Fantastic. What a fascinating presentation, and inspiring for the students and faculty from around the world. Thank you, Charl, and thank you, Clive, and of course, thank you, Armin, for your introduction to these wonderful tools. We have a few comments and questions. I put out a few people from the audience to maybe they want to chat, but I've got a professor from University of DC, Devdas Shetty. You had a question. You want to just open up, Devdas?
Yes, you can hear me, right?
Sure.
Yeah, I have two questions. It is a very good presentation. The first question is in the area of design for manufacturing applied to additive manufacturing. You showed a couple of examples. So do you have a system where the instructor, professor can develop general guidelines for additive manufacturing and teach the students those guidelines and then show a couple of examples? So that is the first question. The second question is in the area of Altair's software called Embed, so which is used for simulation modeling. And then my interest is actually the control part of it. Like I have seen, and we have used the Embed with some kind of a control of some toolkits and Arduino boards. But have you done anything more in that area, like any of the Altair tools for control strategy? So these are the two questions. First one is on additive manufacturing. Second one is on control. Thank you.
Okay, great. I'll take that. In terms of what we're doing, and I'm quite sure this is a challenge faced by many of the academics out there, is how do you build in the DFAM mindset into your current curriculum without really overloading the students? And that is something that we are still working on. I know that a lot of the international universities are offering taught masters or additional courses where DFAM mindsets and strategies are discussed. Because I'm sure, just like us, a lot of our original content has been based on subtractive manufacturing methodologies. And that's a major challenge. We've also looked at how we can simulate it into our design courses without disrupting that too much. And it's still very much under discussion. I've even looked at developing an online course, but there are many, many out there that are available. So our primary challenge here is where to fit it in so that we do not overload the students, yet it is a critical need. There's no two ways about it, because from the projects we have definitely seen that the guys tend to come in with a subtractive mentality, and that's an entirely wrong way to approach any additive manufacturing project. Just the same way with regards to a composite design project. If you do not have the manufacturing process in mind from the onset, you are really climbing a very steep hill. The second question, with regards to embed, we had access to compose, embed, and activate, which were the three packages. Charl did play around a bit with activate, I think it was, in the initial design of his robot, but we had to leave things at that stage because he was facing time constraints in terms of a hand-in. Now, I know that those projects have been repackaged, I think, into a suite called SmartWorks, but maybe Armin can give more information on that.
Okay.
Armin, you want to jump in?
Yeah, thank you.
Yeah.
Yeah, I can try to to add something because Clive gave a very good answer on this from the practical point of view. So from our side, from Althea, I can say that we have, I would say, Compose and Activate are our most tools that are most used for design of control systems, and embed later on to create the embedded code of the device itself. So especially for helping students getting familiar with control systems implemented in Activate, we have created these digital twin package with a Chrome where you combine the reality, the ball balancing table with the control system and the virtual world in an MBD simulation model. And that is a good way to get students familiar with the control system and the digital world and the reality itself.
Thank you.
So thank you, Devdas, for your question. Any additional comments you have? We can ask.
No, yeah, thank you very much. Yeah.
Let's see anybody else from the panel who have any comments. I'm going to see if Ala Ashmawi from our IFEES president.
Krishna, I want to talk. Krishna from India Money wants to just. Okay, I want to say something.
We'll get to you as soon as we get done with Ala. Okay, after Ala, we'll come to you, Money. Okay, just a minute. Okay,
sure.
Ala, come in. Yeah.
No. I was fascinated by the presentation, just like you, Krishna, and especially the material that Clive presented was just fascinating. And I think the question that I had was already asked by the previously, and that is how to find space in the curriculum to cover all of this. But I'm really grateful for an excellent presentation.
Thank you, Ala. Come in, Mani.
Thank you, Krishna. That was an excellent, comprehensive presentation covering the future technologies, especially the digital manufacturing, IoT, as well as machine learning. In fact, I'm very much interested in learning about that Althea partner alliance, in how we can partner with you to thing is for the students as well as for the faculty in terms of the project as well as for research, especially from some Indian universities. They may be interested in partner with Althea So I need some thoughts in this particular thing.
That's a good question from Mani. We have almost more than 250 people here, and many of them are from India, from universities in India. So maybe you might want to shed some light on how they can move forward in this direction.
So beside I think it's 100 tools that Althea has in its own portfolio, we partner with external vendors and developers of simulation software, and we combine the licensing system. So their software can be licensed through Althea units, and can be included as well in a education license, non-commercial license provided to universities. But this is a case-by-case basis. There's a list online. I can share the link on Althea University, where you see the list of the partners who have agreed on participating as well in the academic program. But for sure, reach out to me, or maybe you're in contact with Althea already in India. Reach out to us and get a direct quote from us, tailored to your situation and what partner tools you are interested in and you need to use as well for teaching, for research. Let us know.
Okay, great. We also have the Reyes Ferdinelli from Althea here. Would you like to make a few comments, Reyes? You can unmute yourself and come in if you are in that position to do that. Otherwise, we will have to start winding up.
There
Darius is here. He is there. He is. He's coming.
Now.
Yeah. I will not share the video linkage here, but the only thing I wanted to add is our program is really focused on helping the schools and the students out. And as you saw from Clive's fantastic presentation, how we can be of help and what we would like to see. This is ultimately what we want the schools to provide, because industry is really in need of these type of research and projects being handled by the students in the schools. And so as we partner with the schools and they ask for our help, we will continue to provide that to get them to their ultimate goal of having fantastic programs, projects, and having their students really prepared for the next challenges that they'll be faced once they leave the school. So, but Clive's presentation kind of really summed it up well, and that's what we try to do for all schools.
Okay, great, Darius. We need to wind up now with Hans. Come in, Hans. Closing comments.
Thank you very much, Krishna. I really want to take this moment on behalf of the IFEES and GDC and IUC community to really thank you, this team of Althea and of the Nelson Mandela University, and indeed a very inspiring presentation. And we have present with us today, obviously, many of our colleagues from India, but also many other parts of the world that I know will be very interested to find ways to continue this dialogue. I just want to make a couple of comments. This whole notion of developing a program of virtual internships, not only in terms of between universities, but also with our corporate colleagues, is very important. And in the GDC, we've begun that. And I just wanted to plant that seed to follow up on other dialogues about that. The other thing, the engagement of students within our global work is fundamental to us. And unfortunately, we cannot meet this year in November in Cape Town for our global conference. We'll have our virtual conference this November. And I invite all of you, the faculty, the students, and the leaders, deans, and so forth, friends at Nelson Mandela University.
Be happy, be safe, be healthy, and take care.
Thank you very much.
Thank you. Peace be with
Thanks
you.
very much, guys. It was an absolute pleasure. Thank you.
Thank you.